Hey everyone, this is Dr. Walker. Somebody asked about the practice questions, number 1 on v038C. They asked about it during the help session and we were just running out of time. So I said I'd make a quick video. So the problem said that there was a force applied to push an object that had a certain mass and it moved it from position 1 to position 2. And we're trying to find the work done by this force. So the first thing when figuring out work is we have to know if the force is constant or not. In this case, it's a constant force, right? The force does not depend on x or any other variable. So when the work is done by a constant force, we can do the dot product, F dot delta R. Now here we are given the position 1 and position 2. So to find delta R, we just go to the side and we just subtract the deltas. So delta R is just R2 minus R1. And if you want to visualize this, you don't have to, but just, we have extra time here. You can fast forward through this if you don't want it, but it's nice to visualize things. R1 is 1, 1, right? So let's say right here, this is R1, and then this is R2, 1, 2, 3, 4, -1. So R2 is over here. So we're moving from position R1 to position R2. We're going from here to here. And I am arguing or letting you know that this delta R is just R2 minus R1. Remember the tip to tail method? If you draw the R2, and then if you do minus R1, you just put R1 in the opposite direction. This would be negative R1 here, right? And this is R2 over here. And then you can see that R2 plus a negative R1 is the delta R. But anywho, so delta R is R2 minus R1. So it's going to be, when you subtract vectors, you just subtract the components. So 4 minus 1, which is 3i. And then minus 1 minus 1 is negative 2j. That's in meters too. And now we are ready to find a dot product. And as we said in the help session, if you have a force like this, you know that what's in front of I is the x component of that force. What's in front of j is the y component of that force. Same thing for R. What's in front of I is your delta x. What's in front of j is your delta y. So when we do a dot product, we just multiply what's in front of the i's and we multiply what's in front of the j's. So we're really doing fx delta x plus fy delta y. So we're multiplying the i's 2 times 3, which is 6, plus 3 times -2, which is -6. And that's how, for this question, we ended up with 0 work done by this force, just because they happen to all cancel out. But it is definitely important to be able to take that dot product when you have that constant force.